This video is about neutralization reactions. In a neutralization reaction, an acid and a base react to make a salt and water. So a salt is not necessarily table salt or sodium chloride. Like when we say salt in everyday life, we almost always mean sodium chloride. But salt in chemistry terms means a cation, from a base and an anion from an acid getting together. It's just, a cation and an anion. So it can be, not just sodium chloride, but magnesium bromide or calcium fluoride. These are all examples of salts. So here are examples: H2SO4 plus calcium hydroxide, CaOH2, two hydroxides, react to form calcium sulfate and water. So we've got in this reaction, let's get out my pen. Here is our cation, Ca, from our base, and then sulfate is our anion from our acid. So calcium is our cation from our base, sulfate is our anion from our acid. They get together. This is our salt. So it's more like salt in a chemist term, not necessarily everyday life. Everyday life kind of narrows it down to just sodium chloride, but we think of it more generally. Okay, so we want to be able to write a neutralization reaction. Write the equation for the reaction of HNO3 aqueous, so nitric acid, and calcium hydroxide, CaOH2 aqueous. Write the formulas of the reactants and locate the anion in the acid and the cation in the base. Okay, so the anion in the acid, well, it's not the H, it's the NO3. And then, so the anion is NO3. And then in the base, we're going to have the cation, so it's right here, and the cation is Ca. So we're going to put them together. Ca is a 2+, and NO3 is a minus. So for every Ca2+, we're actually going to need 2 of the NO3 minuses. Okay, so we're going to have Ca and then NO3, and then 2 of those nitrates we know are always aqueous, plus we have H getting together with OH. We want to be able to recognize water as HOH. When you have H plus and OH minus, that actually is water because that's 2 H's and an O. So when H gets together with OH, that makes water. And then what you might notice is that it's probably not balanced. Cool fun fact about balancing. Well, the coefficients of the salts are always 1. So that will be kind of fun. We'll get to that here. Okay, so we put together our salt. We've got Ca2+, and we've got NO3-, and then we make liquid water. Now, I'd rather just kind of put them together right away, which was what I did. But anyway, CaNO3, and there's 2, and then there's liquid water. So we need to go back and balance the equation, and the coefficient of the salt is always 1, so that's kind of fun. We put a 1 here for calcium nitrate, but we need 2 of the nitrate ions, so we go put a 2 here in front of HNO3. Well, that kind of makes sense because if there are 2 H's alone and 2 OH's alone, there are actually 2 of the waters if we think of water as HOH. So we'll need 2 water molecules because if you think about it, we'll need 2 of the H's alone and 2 of the OH's that make up the water. 2 H's, 2 OH's, 1 calcium, and 2 nitrates. So 2 in front of HNO3 and 2 in front of water actually gets it all balanced. Okay, let's practice with these equations. We've got magnesium hydroxide solid plus HCl aqueous reacts to form Well, let's figure it out. First, we need a salt. For the salt, we're going to have the cation of our base and the anion of our acid. It's really one of those rainbow double displacements where magnesium gets together with the chlorine. Now, magnesium is a 2 plus and Cl's a minus. So it will take 2 of the chlorines. So we'll have MgCl2, and that's an aqueous salt. And then we'll have H getting together with OH. So H gets together with OH. And when H gets together with OH, that makes water. And we'll put water liquid. Okay, we can check and see if we're balanced here. Let's do Mg's. Let's do OH's. Let's do H's alone and Cl. Now we can rethink of water as H and OH for the purpose of balancing. It actually usually helps. So 1 magnesium, 2 hydroxides on the left, 1 H alone, 1 Cl. On the right, 1 magnesium on the product side, 1 OH alone, 1 H alone, and 2 chlorines. So, for example, we need 2 more chlorines on the reactant side, but that will change us to 2 H's alone. Well, 2 H's alone and 2 OH's on the reactant side really means we need 2 waters on the product side. So that we'll have 2 H's and 2 OH's. So for the purpose of balancing, thinking of water as HOH is kind of helpful. And it also helps us, think of how H gets together with OH to make water in the neutralization reaction. Okay, let's try the next one. H2CO3 aqueous plus LiOH solid. Okay, well, let's think of our double displacement. H is getting together with OH. Well, we know that just makes water. And then Li is getting together with CO3. Remember the cation from the base with the anion from the acid. Li and CO3. Now, Li is plus, but CO3 carbonates a 2 minus ion. So we'll need 2 of the lithiums to get together with the carbonates. We need 2 lithiums for every carbonate. Then we need to balance. So again, we can do, let's do H first. Let's do H's alone. Let's do CO3. I'm out of room here, so I might have to do these separately. Let's do lithium, and let's do OH's. We're just making separate little lists here. On the reactant side, 2 hydrogens, 1 carbonate, 1 lithium, 1 hydroxide. On the product side, there's actually 2 lithiums. There's actually 1 carbonate. And then remember that water can be HOH. So with water, there's 1 H alone and there's 1 OH. Well, we know we for sure need to double the lithium. So let's go double the lithium on the reactant side, double the OH on the reactant side. It looks like on the reactant side, there's twice as many H alone and OH, which really means we need to double water so that we double H alone and OH on the product side. So I like to think of water as HOH just for the purpose of balancing. I know it's H2O, but it works for balancing acid-base reactions where on the reactant side, the acid had H plus and the base had OH minus. Okay, so, let's go back and actually label our salt in each of these, because remember, in acid-base reactions, we can actually label all of that. In acid-base reactions, there's always an acid that starts with H plus. There's always a base, oftentimes has hydroxide, and you always make a salt and water H2O. So again, acid-base reactions, we've got our acid starts with H. We've got our base with hydroxide. We're always making water And here our salt is lithium carbonate. So going back and finding the salt, I think, is helpful when you're finished with an acid-base neutralization. Make sure you made a salt and water.